Good afternoon and welcome to our highly anticipated technical seminar, Engineering the Future. I'm Kevin from Thai, Malaysia, your host and MC for today's event. Am I delighted to see such a fantastic turnout here today. We have an engaging program line for you. Our esteemed speakers will share their invaluable insights and experiences. Before we proceed with the presentation, I'd like to take a moment to thank all the attendees for being here today. We truly appreciate your participation and engagement. Without further ado, let's begin our seminar. Allow me to introduce our first speaker, Mr. Colin Koh. With over 30 years of experience, Colin has provided mentorship and advisory services to regional SMEs, guiding them in implementing digital transformation aligned with the emerging Industry 4.0 concepts. Colin's expertise extends beyond his impressive resume, as he has authored 2 books, Smart Factory and Industry 4.0, Navigating Manufacturing in ASEAN. Let's give a warm round of applause to Mr. Colin Koh.
Okay, good afternoon. I hope you'll have a good lunch. So today my topic is talking about the challenges and opportunity for engineers in the era of the Industry 4.0. So as you know that the Industry 4.0 has been a term being used very widely for the last 10 years. So Industry 4.0 already 10 years old, right? So I will explain a bit about the Industry 4.0, especially the technology portion, and how does that relate to professionals like you, consulting engineers and practitioners. Okay, I think last 10 years we have been hearing a lot of terms like, for instance, smart infrastructure, smart city, smart grid, smart building, smart manufacturing. So why this term smart come about? I think it's about the technology advancement allow a lot of processes, technology, and even the way that we work to become smarter. So this is why I think this term start to surface. So I think in terms of the construction industry, like smart buildings, I think it's more relevant to you, or even I think the smart manufacturing is all required a lot of technologies. I think more and more technology will be used in all these infrastructure, could be building, railway, smart grid, even smart home, right? So how can engineers leverage on all these Industry 4.0 technologies to ensure that whatever they design is really up to date, and also first thing first is up to date, allow the user to be more productive, more efficient, and better still safety aspect also come into play, right? So I think this is where the Industry 4.0 has been quite pervasively being discussed the last 10 years. Okay, I think this chart is one of the latest report by one research company. So the CEO concerned, these are the talk that CEO when they discuss about the business. So if you look at terms like labor market, ChatGPT, which is I think the last few months, a lot of happening going on, Industry 4.0, metaverse, and the economic uncertainty. So these are the main topic the CEOs need to understand and need to see how to eliminate or even take advantage of. So if you look at on the top right hand side, these are the big topic in this growing topic like AI. So the AI, machine learning has been a buzzword, right, the last couple of weeks or even the last quarters. You will be wondering, Industry 4.0 is still being discussed, but the frequency is not so much. The reason is very simple. As I mentioned to you, Industry 4.0 was coined as early as 2013 by German. But even before that, in the World Economic Forum 2011, they have discussed the fourth industrial revolutions. So after the discussion of the fourth industrial revolution, Germans really find that they need to leverage on this fourth industrial revolution to make sure their manufacturing activity will be moved to the next stage. Because you know that Germany is a world powerhouse in terms of the industrial product. In fact, you can see a lot of this machinery, technology, automotive, all the high-end technology are from Germany. But they have also realized that they cannot rely on Industry 3.0 technology because it's already hit the ceiling. So they are looking at how can they leverage on Industry 4.0 to move to the next stage of the industrial revolutions. So since then, I think all the countries are following their step. Right? For instance, China 2025, even Malaysia, you have programs. All the ASEAN 6 countries who involved in manufacturing also have. So worldwide, people are looking at how to leverage on Industry 4.0. The status of Industry 4.0 after 10 years are still ongoing, right? Of course, you know the advanced country, they are actually the early adopters of Industry 4.0. But the rest of the country are still trying to understand. In fact, some of them are trying to understand how can they use. Some are already have some roadmap, meaning they want to build a smart factory. So probably they have a 3 to 5 years roadmap to ensure that they are able to catch up. If not, if you are not doing that, your competitors are doing that, then probably you'll be out of the market. Right, I think that's a natural progressions. So these are the status of what's going on the last 6 months. Okay, I think since all of you are from the engineering professionals, so I think you all know the IEEE. IEEE have a website called IEEE Explore, right? This is what, from IEEE perspective, how to explain Industry 4.0. So you know that first industrial revolution is started in 1784. So until today, is about 250 years. Right? So first industrial revolution take about 100 years. Second industrial revolution take about 100 years. Third industrial revolution take about 50 years. Right? So I suspect the fourth industrial revolution probably will take shorter times, maybe about 30 years. The reason is very simple. Because the technology are moving very fast, because of the semiconductor, because of communications, because of the software, right? So all this technology actually come together. Later I'll explain all this technology, and as compared with the last 3 industrial revolutions, the fourth industrial revolution actually allowed enterprise or even government to have exponential growth in terms of productivity, efficiency, if they are able to leverage on this technology. Of course, at the end of the day, they need to have a very skilled workforce, right? And also those people who are in the planning, they are able to have a very long-term viewpoint of these technologies, right? So these are what is going on. So you know that Industry 4.0 is talking about cyber physical, and the first industrial is talking about steam engine, second is electricity, third is the computing. I will talk about a bit more about these 4 revolution and how does it relate to your daily life, and moving forward, how can you leverage on these technologies, right, in your professional work. Okay, this, I tried to revert this chart, right? So Industry 1.0 to Industry's 4th Industrial Revolutions. I want to take in terms of the engineering perspective. So I'm sure that all the engineers are being trained, right? When you are, whether in the graduate or undergraduate or whatever. system engineering is one of the topic you all have to go through. The reason because engineering cannot operate in a silo. In the industry 1, 2, 3, I think some of this technology you still can stand alone to do it. But Industrial 4.0, you are talking about integration of the old technology together with the new technologies. Right? So integration become a very important topic, and system engineering is also become one of the fundamental skill set all the engineers need to master, right? So this is one of the reason I come out this chart. So if you look at this 4 circle, right? So I will explain in terms of the revolution and also the technology they invented during that period. So you know that first industrial revolution is a steam engine. So actually it's talking about replacing human labors with mechanical force. So a lot of times the engineers are trained in mechanical and also physics. So physics is also relevant to materials. So a lot of new material science also developed from these revolutions. The second revolution I think is more close to heart to all of you, right? It's the invention of electrical systems. That allowed, in the first industrial revolution, if you want to build a factory, you have to build a steam engine plant beside the factory to move the mechanical parts, right? But not all the factory owner can afford to do that because it's not cheap. But after the second industrial revolution, the invention of electricity allowed the energy to transport from a central location to a very far distance. This is where you can see a lot of mid-sized, small-sized factories start to set up. And also during this period, we are talking about mass productions. The reason is you are able to do mass production during that period, right? Is because the worldwide demand is more than supply. That's to say the manufacturer, whatever you manufacture in the mass, in the bulk, very likely that you can sell to the market. So there's no issues. Right, so this is where the mass production era started in the second industrial revolution. So since the 1960, 65, you can see we have moved to another level of technology advancement with the invention of the semiconductor. So you know the semiconductor was able to exponentially grow. Right, just like the Intel founder said that every 18 months, the chips density will double every 18 months. And until now, that theory still holds. But I suspect they already hit the so-called the ceiling because in physics, there's so much you can grow, right? So I think they are talking about 1 nanometer chips, which is very difficult to manufacture. And at the same time, he more or less already reached the physical limitations. You cannot do any more smaller, right? So people are looking at new types of material, new types of chip design coming in, right? So I think a lot of this thing is under development. So during that period, 1960 until maybe 10 years ago, a lot of advancement in terms of electronics because of the semiconductor chips. At the same time, we know that a lot of these new media, for instance, the wireless, the mobile, all the communication infrastructures start to, develop and become very cost-effective that everybody can use. So if you look at these three technology, right, mechanical, electrical, electronics, and ICT, we give a term called GPT, right? It's called general purpose technology. Right? This term actually has been used the last 30, 40 years. Right? So it's different from ChatGPT, right? It's general purpose technology. Because why it called general purpose? Because all this technology will be used by all the industries, whether you are industrial, commercial, you will be using all this technology to do your daily work. So come the fourth industrial revolution, the industry 4.0 era, which is We have been, until now, 10 years already gone. This Industry 4.0 actually comprises of more than 10 technologies. That's to say that the first one, second one, third one, you have one or two, so-called we call GPT. But Industry 4.0 now, you are having about 10 new technology, and we actually can imagine that maybe out of these 10, maybe 5 of them will become GPT. So you just imagine that you got so many of these general purpose technology to help you to do your work, to do your planning, to do manufacturing or whatever you want to do, right? So it's a very exciting time, but also it's a very challenging time because we are talking about engineering now. You need to learn so many new technologies, right? But I can assure you that you don't have to worry about technologies, right? Technology at the end have to become very friendly, have to become very invisible to use. Just like how you use a handphone. You don't have to understand what is inside a handphone. You as a user, you make use of a handphone to do your daily work and you achieve what you want. And that is the ultimate aim of the technology. They have to mature to that stage. So you don't have to be AI scientist, or you don't have to be maybe cybersecurity engineers, but you have to understand all this technology. What does it mean to you, right? As a designer, as a user, right? So this is where we talk about all this. So if you look at, in terms of the developments from the first to the fourth industrial revolution, we are moving from physical, right? For example, mechanical part you can see, you can touch, to so-called cyber. Cyber, for instance, I give example, let's say now, maybe 20 years ago, you can never imagine that you can talk to somebody in real time in all over the world using maybe Zoom or maybe Team, all this technology. But now it's possible, right? So you are moving from a physical to a cyber. So physical is also related to tangible, meaning you can really touch it, you can see it. But a lot of times when you use this technology, it's intangible, right? You can realize the value, but you cannot touch it. Somehow you cannot feel it, right? So that is advancement in terms of the technology perspective, right? And also in terms of the how the technology have moved from so-called physical to cyber, from tangible to intangible, right? So this is where I think industrial revolution allowed people to move from a very physical activity to now you can see a lot of industry actually move into services. So services is actually based on the tangible product. You build on top of what can you use, how can you feel, right? Just like you use Grab, you use all the e-commerce stuff, right? So I think that is the situation that we are in now. Okay, so if you check with the IEEE Explore, you are likely to check all this information because all these are research papers that published and submitted to IEEE, right? So you look at all this Industry 4.0 technology like big data, system integrations, Internet of Things, right? All these have become a very hot topic, right? That actually discussed by engineers. So what I'm trying to say is all this information and knowledge actually are available to you. So I don't think you need to become expert, but you just need to understand where are they coming from, how does it integrate with other technology, what is the application, how you calculate the total cost of ownership, right? So I think you have to look at all this as an engineer professional or as a consultant engineer when you want to submit a proposal to your end user. So these are a few things that probably you need to look at. So I understand that. I don't think you need to take picture because I think Kelvin will be sending my PDF slide to you. So maybe just relax and listen, okay? So okay, this is a situation from IEEE perspective. Okay, so if you are in the smart grid, okay, I think you know that smart grid consists of 3 portions, right? From power generation, power transmission to power distributions. These are 3 pockets of the power industry, and they are trying to use how can they leverage on Industry 4.0. to ensure the whatever energy they deliver to the end user will be more efficient, have more safety, right? And of course, cost effective. So they are thinking very hard because everybody are using energy. How can you use the energy at a lower possible cost to do your daily work? So this is where the power industries professional, they are thinking very hard in terms of how to use all this technology into their design, into their implementation, into their projects. Okay? So this is another perspective to look at the, I think if you are in construction, you are likely to use the BIM, right? So BIM is a building information modeling. So BIM is a very digital technology, right? So this is why I think since Industry 4.0 and also Fourth Industrial Revolution, the terms start to come out, we call it digital transformation. Meaning how can you transform your daily life with embedded more and more digital technologies. So a lot of this analog technology, physical technology, you need to see how to convert them into digital. Because the moment you're able to convert into digital, you're able to share with a lot of people, right? And also all the different so-called disciplines will actually integrate together more seamlessly and also sometimes in real-time format, right? So that is an ultimate aim of the so-called this BIM and Industry 4.0 technology relationships. So same thing, I think in the constructions, they are using all this technology to see how to do planning, right? So the product life cycles and the project development life cycle, all this, they are trying to make use as much possible, all these technologies, right? Because in anything that we do, we are looking for productivity, efficiency, safety, right, and quality. These are the four objectives for all the manufacturer, for the designer, for the end user. They are looking for all these four outcomes that they want. So you have to see how all this technology can be integrated to achieve all these outcomes, right? So I think it's quite fundamental in terms of what the end user wants. Okay, so as I explained to you, this is where the four industrial revolutions. So as you know that the latest one, as I say that, so another term people say ChatGPT. When they say ChatGPT, is actually GPT is a term they use, a generative pre-trained this transformer, right? These are three terms that they use. The transformer is a technology that developed by Google. So actually ChatGPT using this transformer technology to develop their product. So as you know that now many things happen, right? People think that in the past, I think you need to spend hours to come out, maybe to write a report, to write a research, maybe to do some maybe craft some email or whatever. You're able to use ChatGPT to do it very fast, very efficiently. But of course, ChatGPT is doesn't mean that it's perfect, right? Because all these are actually digital informations, and they are using algorithm, and they are using a lot of past informations. So they may not able to give you a very good predictions because it's all based on historical data. And also sometimes the result that you want may not be verified. So you have to be careful, right? So you have to selectively, this is allow you to come out something very fast. But as a human being, as an intelligent professional, you have to really check through all this. And to me, very simple. Even I use ChatGPT, I will still, sometimes if I find that information is not really true, I will still go back to this Google search. Because Google search tends to have more verified data. So you have to really counter-check each other. So you cannot just blindly use ChatGPT to do everything that you want. So the human in the loop is still very important to verify all this information. Okay? So from the engineering perspective, I think we are looking at a lot of these new technologies And also, as engineer, I think you probably have a more capability and skill set to understand all these technologies, right? So rather from those upstream students, probably they may be not so easy to understand. But I think as engineer, you have the advantage, right? Since your fundamental is trained in all this engineering stuff, whether software, hardware, or firmware, you're able to grab this technology faster. But the thing is how you ensure that you are able to integrate all this technology to do your daily work, right? As I said, as an engineer, you have a lot of responsibility, but you also ensure that the technology you use is going to help you, right? So I think selection of technology is very important. So more than these 10 technology, the Industry 4.0, as I mentioned, you no need to understand all of them. You just need to see what is your job day, what's your task that you want to accomplish, what's your goal you want to accomplish, and from there you work backward to select the technology that's relevant for you to achieve what you want to do, right? So I think that's where from engineering perspective, I think it's very easy for people like you to understand. So of course there are a lot of this opportunity, as I mentioned, right? Because in the Industry 4.0, as I mentioned, a lot of times you use this technology in a silo, right? So a lot of innovation is limited. But if you are able to combine all this so-called GPT, right, general purpose technology, probably you are able to come out a better process, better innovations, or even a better business model, right? So that allow you to have this opportunity as engineers to see how can you leverage on this technology and whether to grow your career or maybe develop new product or maybe come out some new business model, right? So I think you know that since the internet, a lot of this new business model has been developed and we're now enjoying it. But I think with all this new technology, especially like AI technology actually coming very strongly, don't have to worry about AI, right? Just treat AI as another tool, right? The AI will become very friendly, easy to use, and the cost will also go down. And AI will go into a vertical stream. So for instance, there'll be AI for healthcare, AI for engineering, AI for power plant, you know. So it really depends on the domain. So you must have your domain knowledge. So once you have this tool, you're able to ensure you're able to do a better job, right? Even you still stay at your same, let's say, responsibility. But with the new tool, you are able to do it faster, better, and cheaper. So of course, as I mentioned, it comes with the challenges. So the challenges is, I think, is facing this challenges is facing not only at the individual level, but you're also facing this challenges at the, let's say, institution like the university, even the government, right? And why is a challenges? Because all these new technology are very, very, very new, right? So you must have a mindset. The mindset is, I need to learn new things almost on a daily basis, right? And once you have this mindset, it's easy because all this information are available, right? In your smartphone, whatever. It's only you know where to find them. It's there, right? So once you have a mindset change, I think it's very, very easy to deal with these problems, right? So I think government also see this issue. This why I think Singapore government, Malaysia government, all the government, they are trying to see how to attract all these professionals which is working in the field, which is graduated maybe 20 years ago. How can they be reskilled, right? So there are many courses sponsored by government. I think Malaysia, there are a lot of courses. You attend it, it's almost free. But the only sacrifice is you need to spend your time. So the mindset change is very important, right? So in terms of lifelong learning, the kind of thing, reskill, upskill, right? Okay, these are so other than the technology, I think because of the integration, as I explained to you, the integration, the system know-how, system integration. In the past, I think in the industry 3.0, sometimes you can still become we call individual contributors, meaning you are still able to contribute to the corporation or maybe whatever organization you have, but just focus on what you are doing. You are still able to contribute a lot. But Industry 4.0 and things like that, we are looking at system integrations. So you have to work with a lot of professionals, your colleagues, maybe even with the different industry. Because let's say a construction project is very complex, right? You have civil engineering, you have mechanical, you have electrical, you have in the so-called the building automation systems, you have all the safety aspects. So all these will be in future, people want to look at all this in real times, right? So because of that, you have to share your information. You also need some information from your colleague or other counterpart. So you have to develop a very skill set that you are able to communicate well, right? Explain well what you want, and also you're able to negotiate what you want, right? So these are soft skills, right? So new types of training like design thinking, agile project management is become, in fact, the last 10 years become a very hot topic. It's because of Industry 4.0 and because of the changes in terms of the way the company work, the way the company work, and how the company work to comply with the government regulations. So this is, I think, need a lot of interaction, so a lot of soft skills, especially the communication soft skill, and also the skill of using all this technology become very important. Okay, so I will not go into individuals of all these soft skill because I will promise that I will send you the slide. So this will be giving some more details, right? So I think if you are somebody who in charge of resources, you want to send your engineers. So you, other than technologies, the soft skill, do you think certain people they have lack in certain soft skills? Then you can actually enhance this portion. So that at the end of the day, I think all organization is basically made of people, right? So if you have people being trained properly, I don't think you have problems. The technology is easy to deal with. It's the people that use the technology have to be very skillful, right, to achieve the result you want. Okay, so as I say, I will not go into detail. So the impact, as I said, the Industry 4.0 impact on different level, right? On the government, on enterprise, academic, also individuals. So you have to ensure that you are part of these ecosystems, right? So understand the ecosystems, where is a contribution you can have, right? By using the tools that you are able to master. Okay, so in summary, is I say that don't have to worry about technology. I think as an engineer, I think you have advantage to understand technology better than the rest of people who are not being trained in STEM. STEM is called the science, technology, the STEM, engineering, and the math. Right? So I think you are trained in that. So it's easy to pick up all this technology as compared with other. But I'm sure that as I said, the technology also will become very friendly. That become very common tools for everybody to use, right? Okay, I think this is my presentation. I hope I've shared something valuable to you. So maybe I want to invite maybe some question. Because the next speaker is going to last for two hours. And he's going to go into very detail in terms of your profession, which is cable design and kind of things. Okay? Any question? If not,
Okay, we thank you for the insightful information regarding the Industry 4.0. Now we would like to open the floor to for any question you may have with Mr. Colin. Any Q&A?
Yes.
It's all well and good, but the cost. What's the cost element for us to adopt technology?
Okay, I think that, as I said, technology, actually automation and technology in the past are not cheap. Even today is not that cheap as well. But what you have to look at from cost, from your outcome that you want to achieve, right? By using the technology, you have a cost. Either spend time in training, acquire the technology, maybe you need to maybe come out some tender, some money to acquire this technology. But you have to understand what you want to achieve. Let's say a factory. I give example. Let's say a factory. Maybe take the factory like maybe Tyson. Your factory, when you manufacture a cable, if you look at the cost structure of cable, actually maybe about 70 to 80% go to raw materials, like copper, all these extrusions. 20-30 is go to sales, marketing, things like that. But if you find that your raw materials and all this copper raw material is occupied a very high percentage of your cost structures, you have to ensure that there's no wastage in this area. Meaning, when you do your production, you shouldn't have wastage in all this expensive raw material, right? And that's what says that your machine must operate very efficiently. So for instance, I think in Tyson factory in Singapore, we have implemented Industry 4.0. Well, I think we have able to achieve many different many advantage. So first thing first is I think the managers who are in charge of the production, they are able to get more or less real-time information, right? Maybe in the past it take maybe 2-3 days to tabulate information, but now you're able to see maybe the next morning. But the next stage probably you want to see real times. So this is one advantage. Second advantage is once you have the visibility, you are able to reconfirm whether you have the right process. Because a lot of times, when I speak about this Industry 4.0, I only tell them 3 things they need to understand. Only 3 things. First is your people. Do you have trained people? Right? Secondly, do you have a logical process? If you do not have a logical process, you are wasting a lot of material and times. Because time and motion is also a wastage. The third one is only technologies. So you train your people well. Your people, once your people are being trained, they will understand how to put the process in logical manner to save cost. Then it's still not enough. You think that I think this technology I cannot use human. For instance, let's say I need to check my cable size, right? So maybe in the past you need to, at the end of the day, take some sample, they go to the lab and check. But I think you can use technology and you can have real-time checking. The moment the size is out of spec, you will stop it. Rather than when you run for 1 hour, all this cable spec is out because the measurement is not there. So technology like this can improve a traditional so-called manufacturing to become more efficient and become more transparent. At the end of the day, of course, you save costs, right? So I think for all the manufacturing, the only thing that you cannot control is the market price. The only thing you can buy, the only thing you control is your cost. The moment you have a low cost, you are able to compete better. Even you are competing with so-called going to compete with price because your cost is low, so you can afford to do that. But if your cost is very high, margin very small, you cannot compete on price, right? So I think that's the advantage of even the traditional manufacturing can use our Industry 4.0 to improve in all this productivity, efficiency, quality, and maybe safety aspect, right? Okay? Yes.
You talk about the cable checking devices or whatever that you implemented in Tyson factory. How do you differentiate whether that particular technology is in Industrial 4.0?
Oh yeah, definitely. We call it inline inspection,
Yeah,
right?
No, I know. What I mean is, this particular technology, it can be developed in Industrial 3.0 also. It doesn't mean you need to categorize it in under Industrial 4.0.
I do see some very advanced factory in other countries. They make use of these technologies. But during Industry 3.0, this technology is very expensive. So you cannot recover your ROI. But now all this technology is become, I think the price have been dropping. Like let's say you are able to, maybe Industry 3.0, this machine, this measurement machine costs you $10,000. Now I think you can get it at $2,000. And not only that, you are able to get real-time data for you to do tabulation, to where you do data analytics. So that's a difference, right? So doesn't mean that the technology is never been used, but it's too expensive. It's not like never been used, too expensive. Another example is, let's say, video surveillance. In the past, also very expensive. But now you're able to get it very cheap and very intelligent and very low cost and very easy to maintain. So that is the technology that, so that some of this old technology actually, because of the cheap design, because of the bandwidth, right? Because sometimes you need to have a very high bandwidth to collect this information, right? Let's say, instead of collect data every 1 minute, now you're able to collect the data every millisecond. So there is a difference between the cost and also the technology. So as I said, a lot of this old technology actually upgrade because of cheap, because of the bandwidth, because of the industrial design, and also maybe because of the new material actually introduced in the market. Okay, if not, I will thank you very much for your patience.
Okay, thank you, Mr. Kwari. So now we'll be having 15 minutes of coffee break. During the breaks, you all can come in front to have a look on our FR cables demo.
早上的时候我们也都是收2个小时。